Oxide.
Alright guys, in this video we will start with KSSM Form 5 Chapter 1. Alright, so we'll start with Form 5 Chapter 1. So this chapter it's called a redox. Okay, we'll learn something called redox. Okay, first of all I need you all to know a few things. Number one, this chapter it's a very long chapter. Yeah, this is a very long chapter. So we will spend about 3 to 4 months. Okay, we will spend about 3 to 4 months to fully cover this entire chapter. Yeah, so this chapter is a combination of chapter 3 form 5 and chapter 6 form 4 for the old KSSM syllabus. Okay, so this chapter is a combination for 2 chapters in the old syllabus. Yeah, so now for two chapters now they combine to make it become one single super long chapter. Yeah, all right, so this chapter has a lot of important concepts that you all have to be very careful. Okay, so first and foremost, so we need to understand what does it means by the word redox. Okay, so the first thing you have to understand what is redox. Okay, what do we mean by redox? Okay, so the word redox is actually come from 2 parts. The first part is the RED. RED is actually coming from a word called reduction. Okay, another one word is coming from the OX. The word OX is come from another words is called oxidation. So redox, the word itself is a combination of reduction and oxidation. So what do we mean by redox? Okay, so what is redox? So redox, the definition is this. Okay, redox is a process. Redox is a process where reduction and oxidation happen at the same time. Okay, so if we have oxidation process and also reduction process, 2 processes happen at the same time, so that is redox. If let's say in a chemical process we only have oxidation, don't have reduction, then it is not a redox reaction. Same thing if our chemical process only has reduction process, don't have oxidation process, so it is not a redox. So in order to be redox, you must have oxidation, you must have reduction, you must have these 2 processes and they need to happen at the same time. Okay, so in SPM if they ask you what is redox, so your answer you can write redox is oxidation and reduction happen at the same time. Yeah, so that is what we need to know about redox. Okay, so here we have 2 very important words. The first important word is called reduction. The second important word is called oxidation. Okay, so we have reduction and we also have oxidation. Okay, so now you need to know for what is reduction and what is oxidation. Okay, so there are total 4 different methods. Okay, we have 4 different methods that can be used. Okay, in order to determine, to decide lah. Okay, so we have 4 different methods we can use to decide whether a process is oxidation or reduction. So today, if we given a chemical process, we want to know the chemical process is oxidation or is reduction. So there are total 4 different methods for us to do so. Okay, so let me show you what are the 4 methods and how to memorize. Okay, so these are the method. Okay, so and then this is the process. So we have oxidation process, and then we have reduction process. Okay, so I'll give you some idea and teach you how to memorize later. Okay, so the first method is called oxygen method. The second method is called oxidation number. So oxidation number sounds very complicated for you now, which is okay, no worry. You will learn that very soon. The third method is called hydrogen method. And the last method is called electron method. So there are total 4 methods: oxygen, oxidation number, hydrogen, and electron. Okay, first of all, let me teach you how to memorize first. Let me teach you how to memorize. Okay, look at the first letter. So look at the first letter. Okay, oxidation, the first letter is O. Oxygen, the first letter is O. So they have exactly same letter. So they have same letter. Oxidation has O, oxygen has O. So when the letter is the same, so you put a sign here, plus. Okay? Same thing goes for another one. Oxidation is O, oxidation number also O. The first letter is the same, so you put plus as well. Okay, next one. Oxidation is O, hydrogen is H. So the first letter is different. So when they have different first letter, you put minus. Okay, lastly, okay, electrons. Okay, so for electrons, so if we use electron method, so how? In front of oxidation, the letter is O. Electron, the first letter is E. So the first letter, they are different. The first letter different. So when they have different first letter, put minus. Okay, so this is a very simple way to memorize. So the letter is the same, you put plus. The letter is different, you put minus. Okay, so reduction, everything terbalik from the oxidation. So for reduction, just terbalik everything. So here we have plus, plus, minus, minus. So if we go for the reduction, just go to put minus, minus, plus, plus. Okay, that's it. So what is this table all about? This table tells us if I want oxidation process, okay, so I can refer to 4 things. Okay, the plus here, all the plus here stand for gain. All the plus here stand for gain or stand for increase. All the minus here stand for lose or stand for decrease. Okay, what do we mean? Okay, what do we mean by this? Okay, so let me go through very slowly. You might find it a bit confusing in the first place, which is normal, very normal, because you are learning and you are trying to adopt a new concept. So if you feel it a little bit confusing, you are very blurred in the beginning, it's completely fine. You will be better as we move on. Yeah? Alright, so what do we mean by plus and minus here? Okay, if today I want oxidation process, so to have oxidation process, I must gain oxygen. Example, initially I have 2 oxygen. After the chemical reaction, I got 3 oxygen. From 2 to 3, I gain oxygen. My amount of oxygen increases. So that process is oxidation. So that's the logic, okay? So same thing, what about the minus here? I take one random one, let's say the minus here. Okay, so if I minus electron, minus means, sorry, minus hydrogen. So minus means lose. So lose hydrogen, so the process is called oxidation. Example, if let's say I have 4 hydrogen initially, before the chemical reaction, I got 4 hydrogen. After the chemical reaction, all the hydrogen totally gone. I got 0 hydrogen, no more hydrogen. So my hydrogen go from 4 becomes 0. So in this process, I lose hydrogen. So when I lose hydrogen, so I will undergo oxidation process. Okay, I will undergo oxidation process. So that is what we need to know. So here we have total 4 different methods, 4 different perspectives to decide whether the process is oxidation or reduction. Okay, so this is a very, very important concept. Okay, I'll teach you another one more concept, then only we will go deep. Okay, we will go deep about each of these methods. Okay, we will spend some time on every single method later. But before we go to that, so let me teach you another one more concept. Yeah. Alright, so another concept that you have to know is this. In this chapter, you will keep on seeing the word agent. You will keep on seeing the word agent. Okay, so first of all, let me teach you a concept first. Okay, the concept is all the chemical substance always be the agent for the opposite process. All the substance always be the agent for the opposite process that itself gone through. Okay, substance will become the agent for the opposite process that itself gone through. Okay, what do we mean here? Okay, let me give you an example. Let me give you an example here. Okay, let's say we have a chemical substance called A. Okay, let's say we have substance A. So substance A itself undergo a chemical process. So this chemical process, let's say called oxidation. So substance A undergo oxidation process. So in this case, substance A will automatic become a special agent. Okay, substance A will become an agent. Whatever substance that undergo oxidation or reduction, when you undergo oxidation, when you undergo reduction, you must become an agent. I repeat, when a substance undergo oxidation or undergo reduction, they must become agent. So what agent they are? The agent must be exactly opposite. Okay, it must be opposite to what it gone through. So let's say substance A undergo oxidation process. So when I undergo oxidation process, I will become opposite agent. The opposite of oxidation is called reduction. The opposite of oxidation is called reduction. So we don't call it reduction agent. We change the sentence a bit. We call it as reducing agent. Okay, so if the substance undergo oxidation, it will be opposite reducing agent. So that is what you need to know. Okay, let me show you another one example. Okay, another one more example. Let's say we have another substance. This fella called substance B. Yeah, let's say for substance B undergo a chemical process. So the chemical process that substance B undergo is called reduction. Okay, let's say now substance B is undergoing reduction process. So when substance B is undergo reduction process, substance B must become an agent, because whenever you undergo oxidation or reduction, you always be an agent. So the question is, what agent is substance B? So substance B must become an agent which is opposite process of what itself undergo. Substance B undergo reduction. So it will be the opposite process, agent. So the opposite of reduction is oxidation. So substance B must become the agent for oxidation. Okay, we don't call it as oxidation agent. We don't call it as oxidation agent. Okay, we modified it, become oxidizing agent. Okay, oxidizing agent. Yeah. So oxidizing agent, it's okay for you to use like this. Oxidizing, some of the book they write OXIDISING. Some of the book they wrote OXIDIZING. So both also acceptable. Okay, so both also acceptable. Yeah, you can use oxidizing agent, you can use the S or you can use the Z. Yeah, you can use the S or you can use the Z. So I hope you can understand this concept. Yeah, all the chemical substance, they will be the agent for the opposite process that itself undergo. Okay, it cannot be the same, it must be opposite. You cannot say, alright, substance X undergo oxidation, then substance X is oxidizing agent. No, that is wrong. Cannot. The process and the agent must be opposite. So if substance X undergo oxidation, it must be reducing agent. Yeah, it must be reducing agent. If substance Y undergo reduction process, so substance Y automatic become opposite, oxidizing agent. So this is something very, very important. Okay, so let's make a very quick recap. Let's have a quick summary before we go on to learn something deeper. So up to this moment, we have learned three concepts. Up to this moment, we already learned three concepts. Yeah. Concept number one. What is the definition? What is mean by redox? Okay, what do we mean by redox? Redox means that we have oxidation and reduction process happen at the same time. Okay, we have oxidation process, we have reduction process, two processes happen at the same time. That is redox. Second thing, we learn there are total 4 different methods. There are 4 different methods that can help us to decide whether the chemical process is oxidation or the chemical process is reduction. Yeah, there are 4 methods for us to do that. Yeah, so the first method is we can look at the oxygen, whether the oxygen is increased or decreased, whether we got more or less oxygen. Second method is oxidation number. So no worry what is oxidation number at the moment. You will learn that very, very soon. The third method is hydrogen method. By looking at whether the hydrogen is increasing or decreasing. So we also can know whether the process is oxidation or reduction. And lastly, we also can look at electron. Same thing, by looking at whether the process is gain electron or lose electron, whether the amount of electron increase or decrease. That can also tell us the process is oxidation or reduction. Yeah, so there are total 4 methods that can help us to decide whether we have oxidation process or we have reduction process or not. Yeah. Lastly, we learn another one concept called agent. Okay, all the chemical substance, if they can undergo oxidation, if they can undergo reduction, they will be an agent. Okay, if the substance can undergo oxidation, if the substance can undergo reduction, they will become agent. So the agent is always opposite of what process that itself gone through. So if the substance undergo reduction process, that substance will become oxidizing agent. If the substance undergo oxidation, that substance will be, okay, if the substance undergo oxidation, that substance will be reducing agent. Yeah, so those are total 3 important concepts that we learned so far. Okay, so next one, now we have total 4 methods here. Okay, there are total 4 methods here. So in this lesson, in this video, we will focus on 2 methods first. In this video, I will cover on oxygen method and also hydrogen method. Okay, we will cover oxygen method and also hydrogen method. Yeah, okay, so let's start. Okay, this concept is very, very important, so I want you to go with me. Okay, so when you first started, you will find it a little bit hard to understand, but hang on there, just follow me, go on with me, and you will get better very, very soon. Yeah, okay, so let's start with the first method. The first method, the simplest method, yeah? The simplest method that we need to know is called oxygen method. So for oxygen method, we will focus on oxygen. Okay, we will focus on oxygen. Okay, we will focus on whether we gain or lose oxygen. We will focus on whether we gain or whether we lose oxygen. Yeah, all right, so how does it works? Okay, how does it works? Okay, so let me show you some rough idea here. Okay, let me show you some rough idea here. Okay, let's say we use a few example as to demonstrate. Okay, let me use some example to demonstrate. Okay, so the first example that we can do is this. Okay, let's say, okay, example number 1. Okay, the first example, I have this Mg plus CuO become MgO and Cu. Okay, please do not memorize. Don't memorize. This is just a normal, regular example for you to learn the concept. Don't memorize anything. Don't memorize anything. Let me just use one example to do demonstration. So your concept is not to memorize everything, but you need to understand. You don't memorize everything. You must understand the logic behind. Okay, so first of all, you must have this logic. Okay, so this is a strategy. Okay, this is a strategy. Okay, whenever, okay, let me write it down. Okay, strategy. Okay, to use any of the four method. Okay, to use any of the four method, okay, for oxidation or reduction. Okay, to use whether, okay, hydrogen method, oxygen method, whatever method, if you want to use this method to play around with oxidation or reduction, okay, you must always do apple to apple comparison. So you do something called apple to apple comparison. Okay, what do we mean by apple to apple comparison? Apple to apple comparison means that you need to choose the right one. You must always choose the right pair in order to do comparison. Okay, so you must compare the right fella, the right pair. Okay, example. Okay, and how you choose the right pair? How you choose the right pair? Okay, always choose one fella, okay, from the left. Always choose one fella from the left, and then you go to choose another one from the right. Okay, choose one from the left and choose one from the right. Okay, one from the left, one from the right, then only you compare. Okay, you cannot choose both from the left. You cannot say, okay, so now I got x plus y become z, so I choose x and y, two further from the left. Cannot. You cannot choose two further from the left. You cannot say, okay, I have x plus y becomes z plus a, so I choose z and a both from the right. Cannot. Yeah, you must choose one further from the left and one further from the right. Okay, so now let me show you how to choose first. Okay, in this example, let's say, so the first apple, okay, let's choose the first apple, apple number 1. So the first further, let's say I choose from the left. Okay, left hand side, my first apple, I choose magnesium. So magnesium is the first further I choose on the left hand side of the arrow here. Yeah, this is the left. Okay, this is the right. So on the left hand side, I choose the first further called magnesium. So now I need to choose one further on the right hand side here. Okay, right hand side, now I got two apples. Okay, I got two apples on the right hand side. One apple is magnesium oxide. one apple is copper. So now I have two further on the right hand side. And I only need to choose one. Remember, I choose one further from the left, which I did. Now I need to choose one further from the right. So now, right hand side, I got two further. I got two options. Which one should I choose? Which one should I choose? I should choose magnesium oxide or magnesium. So if you want to choose, you must choose something which is related. You must choose something which is related with the left hand side. So left hand side got magnesium. Right hand side, supposingly, we will choose magnesium oxide. Because magnesium and magnesium oxide both have Mg. Both have Mg. We won't go to do this, guys. We won't choose magnesium on the left as one apple and choose copper on the right as a second apple. Why? Magnesium and copper totally has no relationship at all. Magnesium and copper totally different. They don't have anything in common. They don't have anything in common. For magnesium, if you choose magnesium on the left and magnesium oxide on the right, at least you can see both have Mg. You can see something in common. You can see something in common, yeah? So you all must be able to choose the right apple, yeah? So when you want to play around with the four methods, it all started with choosing the right apple. It all started with choosing the right apple. Okay, so for now, our first apple is magnesium, second apple is magnesium oxide, yeah? Okay, good. Next one. When we do comparison, strategy number 2 is always be careful with sequence. Okay, we have to be careful with sequence. Be careful with sequence. Okay, what do we mean by be careful with sequence? Just now we know that we will choose one apple from the left and one apple from the right. So after we choose one further from left, one further from right, how to do comparison? Always compare from the left to the right. Sequence is important. When you want to compare, you must start from the left and go to the right hand side. Okay, you must start from the left and go to the right hand side. You cannot use the right hand side to start compare and go to the left. Cannot. Must be left to the right. Must be left to the right. This is very, very important. Yeah. Example, in this case, okay, magnesium and magnesium oxide. When you compare, you must compare magnesium to magnesium oxide. Magnesium to magnesium oxide. You cannot go the other way around. You cannot compare magnesium oxide from the right to the left. Cannot. So remember, the tips is that when we want to do comparison, first and foremost, choose the right apple. First and foremost, choose the right apple. Yeah. So choose one further from the left, one further from the right. After you choose the right apple, compare left to the right. Left to the right. Yeah. Okay, so now let's compare left to the right. Okay, from the left to the right, what you can see here? You can see on the left hand side, the magnesium, okay, has nothing. On the right hand side, the magnesium attached or sticking with oxygen. So on the left hand side, the magnesium, no oxygen. Yeah. On the right hand side, the magnesium here got oxygen. So no oxygen to the case that got oxygen. What happened here? What happened is that in this case, magnesium actually gain oxygen already. The magnesium now gain oxygen. Yeah, magnesium go from no oxygen to become one oxygen. So magnesium gain oxygen. So when magnesium gain oxygen, what process that it undergo? So check back the table. The table is the most important thing. Okay, so you see, so when we have oxygen, yeah, so now when we have oxygen, and when we increase, when we gain oxygen, the process is oxidation. Yeah, when we gain oxygen, the process is oxidation. So magnesium gain oxygen in this case, so magnesium will undergo oxidation. So magnesium undergo oxidation. Or you can write in this way, magnesium is oxidized. Okay, magnesium undergo oxidation, magnesium is oxidized. You can write in this way. Okay, so now we already know magnesium undergo oxidation. So what? So remember, whoever undergo oxidation or reduction, they must become agent. So since magnesium undergo oxidation, so it will be the opposite agent. It will be the opposite agent. So the opposite of oxidation is reducing agent. Yeah? Okay, I hope everyone can see the logic here. Magnesium from no oxygen got oxygen. Therefore, magnesium gain oxygen. When magnesium gain oxygen, so we can conclude that magnesium undergo oxidation process. Magnesium undergo oxidation. So when magnesium undergo oxidation, it automatic become the opposite agent. Okay. So the opposite agent for the oxidation is called reducing agent. Yeah. So that's it. Okay. Let's continue from here. Okay, let's continue from here. Okay, now let's go for the second apple. Let's choose the second apple for comparison. So now I will choose copper oxide as my second apple. So I choose the second apple on the left already. Now same thing on the right hand side, I need to choose one more apple to compare with the copper oxide CuO from my left. So left hand side, sorry, now right hand side I got two apples. So which one I will choose? So we will choose copper, okay, because CuO and Cu, both of them have Cu. At least they have something in common. Yeah, they have something in common here. Yeah, all right. So now copper oxide to copper. Remember, when you want to do apple to apple comparison, the sequence must be left to the right. Must be left to the right. Yeah. So now on the left hand side, the copper got oxygen. On the right hand side, copper don't have oxygen. Yeah, on the left hand side, the copper got oxygen. On the right hand side, the copper don't have oxygen. So what happened here? So we can write like this. So in this case, we can write, okay, in this case, we can write, okay, CuO, copper oxide, lose oxygen. Okay, copper oxide now lose oxygen because from left hand side CuO got O, go to right hand side Cu don't have O. So the copper oxide, the oxygen gone already, lose the oxygen. So when copper oxide lose oxygen, so what process that it undergo now? So let's look at the table again. So now if we look at oxygen and now we lose, we lose oxygen. So when we have a process that lose oxygen, that process is a reduction process. Yeah, that process is a reduction process. Okay, so copper oxide lose the oxygen already. So therefore, copper oxide it's undergo reduction. Okay, copper oxide undergo reduction. So if you don't want to write copper oxide undergo reduction, you also can say copper oxide is reduced. Copper oxide is reduced. Make it a past tense. Okay, copper oxide is reduced. Undergo reduction. So it's being reduced. Okay, no problem. It's just a way of writing. It's just a way of writing. Yeah. Okay. So now we know copper oxide undergo reduction. Now we know copper oxide undergo reduction. Yeah. So what agent it is? It will be the opposite. So when copper oxide undergo reduction, so copper oxide will be the opposite agent. So the opposite agent for reduction, it's called oxidizing agent. Okay, oxidizing agent. Yeah. So this is the logic that I hope you all can understand. You can see how it works. Okay, I hope you can see how it works here. It's not very hard, but you need some time to really master the concept. Okay, so a quick recap and we will do another one more example. Okay, all right, then we go for another one, tricky one. Okay, so when you want to use the 4 methods, okay, to decide whether you have oxidation or reduction, therefore you need to do a apple to apple comparison. Okay, you must do apple to apple comparison. So to do apple to apple comparison, you need to choose one furler from the left and one furler from the right to compare. Yeah, you cannot choose 2 furler from the left, you cannot choose 2 furler from the right. Cannot. You must have 1 furler on the left and 1 furler on the right. After you choose, you must be careful on how you compare. Always compare left to the right. Left to the right. Cannot do the other way round. You cannot compare right to the left. Cannot. Sequence is important. Yeah? Okay, that's what you need to know. Alright? So now, one more thing to conclude. Okay, just now you can see this process. This chemical reaction, as you can see, magnesium undergo oxidation. Copper oxide undergo reduction. So since we have oxidation and reduction, 2 processes happen at the same time. You can see in this case, oxidation, is it happening? Yes. Magnesium is doing the oxidation. Reduction, is it happening? Yes. Copper oxide, the CuO, is undergo reduction. So the question to all of you are, guys, can I say this chemical reaction is a redox? This whole chemical reaction, can I say it is a redox? The question it is. Okay, the answer is yes. This is a redox reaction because we have oxidation and reduction. 2 processes happen at the same time. Yeah. So if the question asks, is this chemical reaction a redox? You will say yes. If they ask you why, because oxidation and reduction process happen at the same time. Yeah. Okay, let's do another one more example. Okay, let's do another one more example here. Okay, example number 2. Okay, so now let's go for another one example. So let's say for this example, let's say we have a case like this. Okay, we have zinc react with oxygen to become zinc oxide. Yeah. So same thing, don't memorize. Most importantly is understand the concept. Okay. So this equation is not balanced yet. So let's balance the equation. Yeah. So we put 2 on the right and we put 2 on the left. So the equation now is balanced. Okay. So after the equation is balanced, let us start with our redox. Yeah. Okay, same thing. Remember just now, when you want to do redox, you must start with apple to apple comparison. Okay, apple comparison. So let's choose 1 apple on the left first. Okay, now in this case, so we have 2 apples on the left hand side, zinc and oxygen. We have zinc and oxygen. You can start with any one. You can start with any one. Let's say I choose zinc. So after I choose 1 apple on the left, I must choose another apple on the right. I must choose another 1 more apple on the right. So the right hand side only have 1 option. I don't have any other choices. I must choose zinc oxide. I don't even have option. Yeah. So I only have zinc oxide. I don't have other option already. So I'll choose zinc oxide as the apple on the right hand side. Yeah. So now I already have the apple on the left and the apple on the right. So let's do the comparison. So from the left to the right, let's do the comparison. Sequence is important. Okay. Left hand side, as you can see, the zinc come without the oxygen. So the zinc come without the oxygen. Right hand side, without the oxygen. Right hand side, the zinc come along with oxygen. So from no oxygen on the zinc become 1 oxygen on the ZnO. Yeah. So now what you can see here, so from zinc to zinc oxide, you can clearly see that the zinc itself, this fella, the zinc itself is actually gain oxygen. Yeah, the zinc is actually gain oxygen now. Yeah. So now we know zinc gain oxygen. So when zinc gain oxygen, what process it undergo? So gain oxygen, it's oxidation. So zinc undergo oxidation process. So zinc undergo oxidation process. Yeah, remember how you know that? Refer to the table. Yeah, this table will tell us when oxygen increase, it is oxidation. Yeah, all right. So now we know the zinc undergo oxidation already. So when zinc undergo oxidation, zinc will automatic become the opposite agent. Yeah, zinc is automatic agent. So the opposite agent is reducing. Yeah, so zinc is become reducing agent. Okay, sometimes they love to use this word as well. This is the tips. Okay, sometimes reducing agent, in some of the book, they also can write a word called reductant. They can call it a reductant. Okay, and for oxidizing agent, okay, for our oxidizing agent, sometime in the book they will use another words to confuse you. It's called oxidant. Yeah. Alright, so oxidizing agent also known as oxidant, reducing agent also known as reductant. Yeah. Okay, so let's continue with our apple-to-apple comparison. So now we settle the first comparison already for the zinc. So we don't stop here. We can still go on a little bit. So now we can choose oxygen as another apple. Yeah, we choose oxygen on the left. So after we choose oxygen on the left, so we need to choose another one more apple on the right. So as you can see, right hand side, no more apple already. So we use back zinc oxide. Okay, so now some people ask, sir, I thought we used the zinc oxide already. So just now we already compared the zinc and zinc oxide. But now, can we reuse again? Yes. Okay, so another tips you need to know is that when you do apple-to-apple comparison, you can reuse. Okay, like in this case, although just now the zinc oxide already compared with zinc, now when you do apple-to-apple comparison, you still can compare the oxygen with zinc oxide again. You can compare more than one times. It's okay. Yeah. All right. As long as one further on the left, one further on the right. Okay. One further on the left, one further on the right. So compare more than one times is okay. Yeah. Okay. Now let's do the comparison. So now let's look at the comparison on the left to the right. So from the left to the right now, you can see oxygen on the left hand side we have O2. On the right hand side we have O. So both sides also have oxygen. So this is a little bit tricky. Just now it's easy. Left hand side is zinc, right hand side is ZnO. So you can clearly see that this fella has no oxygen and this fella got oxygen. So this is very easy. But now we are comparing the oxygen O2 on the left versus the zinc oxide on the right. So now left hand side got O, right hand side also got O. So how you compare? Then you compare the amount. Yeah, left hand side O2, so you have 2 oxygen on the left. Right hand side ZnO. ZnO, you only have 1 oxygen on the left, on the right, sorry. So 2O become 1O. So lose oxygen. Yeah. On the left hand side, oxygen is O2. On the right hand side, ZnO. So the amount of oxygen change. Okay, now you have to be very, very careful. When you do comparison, please do not, or just ignore the number at the front. Just ignore the number at the front. All the number at the front is only for balancing. It's only for balance equation. Okay, what do we mean? Okay, what do we mean here? Okay, if you look at the equation here, 2Zn plus O2 become 2ZnO. So when we compare the oxygen and zinc oxide, only compare O2 and ZnO. The number 2 in front here, don't bother. Number 2 in front here is only used to balance equation. Okay, the 2 in front is only used to balance equation. So don't bother, because if you consider that, nothing will happen. You see, 2Zn plus O2 become 2ZnO. Okay, on the left hand side, 2 oxygen. If now you consider the 2 here, you have 2 oxygen on the right hand side as well. So then nothing will happen. So cannot. Don't do that. So all the number at the front here only for balancing. All the number at the front only for balancing. When you want to do comparison, do not compare the number at the front. Okay, so just ignore the number at the front, okay, during comparison. So let me write it down. Okay, so for the tips here is that, so ignore the number at the front during comparison. Okay, so when we do a comparison, just ignore the number at the front. Yeah, okay, now let's go back to our question. Okay, so in this case, so we have O2, which have 2 oxygen. Right hand side, ZnO got 1 oxygen. Remember, don't bother 2 here. The 2 is only for balancing. So from 2 oxygen become 1 oxygen. So you lose oxygen already. So here you have 2 oxygen. Here you only have 1 oxygen. You lose the oxygen already. So you can write it down. You can write like this. Okay. So oxygen now lose. O2 lose the O. So O2 losing the O. Okay, from 2O become 1O only. So when oxygen lose the O, so losing oxygen it's reduction. Go back to the table just now. Okay, so when we lose oxygen, so the process is reduction. So O2 undergo reduction. So when O2 undergo reduction, O2 automatic will become the agent for the opposite process. O2 will automatic become the agent for the opposite process. So the O2, it's oxidizing agent. So O2 is oxidizing agent. Yeah? Alright, that's how it works. Okay? So this question has a few important things you must know. Number 1, we still do apple-to-apple comparison. We are still doing apple-to-apple comparison. We're still choosing 1 apple from the left and 1 apple from the right. But this question is very special because, like what I say, it's okay for you to reuse it. Okay, like for example, the ZnO, the zinc oxide, I compared it for 2 times. I compare zinc oxide with the zinc for the first time, and I compare zinc oxide with O2 for the second time. Yeah, so I compare zinc oxide for 2 times. Why? I have no option because I have 2 apples on the left, zinc and oxygen. So when I have 2 apples, I need to do 2 comparison. So but right hand side, I only have 1 option. I only have 1 apple, 1 option on the right hand side. So I need to compare the zinc oxide to 2 different substances for the left. Yeah. So this is something you must know. So here, this is a very important tips. You always can reuse. It's okay for you to compare and reuse the same fella. Okay, you can reuse, you can compare the same fella. Yeah, all right, that is what you need to know. Okay, next one, like what I say, you need to know all the number in front here when we have chemical equation, like 2x plus 3y become 4z, let's say. All the number in front here is only for balancing. All the number in front is only to do balancing. When you do comparison, okay, when you want to do comparison, don't bother the number at the front. Just look at the chemical formula itself. Yeah? So this is what you need to know. Okay, so let's do one last example for the oxygen method. Yeah? So let's do one last example. Then we will finish with the oxygen method. Yeah? Okay, so this is example number 3, the last one. Yeah? Okay, so for example number 3, okay, let's look at it. Okay, let's say we have this. Okay, we have carbon plus carbon dioxide to become CO, carbon monoxide. Okay, so same thing, this equation is not balanced yet. This equation is not balanced yet. So let's balance it. Okay, so to balance the equation, I can put a 2 here. Then this equation is perfectly balanced already. Yeah, always make sure the equation is balanced before you start with your apple and apple comparison. Okay, always make sure that the equation is balanced before we start with apple to apple comparison. Okay, now let's start with our apple to apple comparison now. Yeah, let's start with our apple to apple comparison now. Okay, so as usual, so now we need to choose the apple. Okay, we need to choose the apple. Choose one apple on the left and one apple on the right. Okay, left hand side, let's say I choose carbon. So I cannot choose carbon dioxide because both on the left. So one on the left, one on the right. So right hand side, I have no other option. I must choose CO, carbon monoxide. I must choose CO, carbon monoxide. I not even have other option. Okay, now from the left to the right, sequence is important. When I do comparison, left to the right, not right to the left. Okay, from the left to the right, as you can see, on the left hand side, the carbon don't have oxygen. On the right hand side, CO got 1 oxygen. So what happened here is that carbon gain oxygen. Yeah, so carbon gain oxygen. So when carbon gain oxygen, so gain oxygen, it's oxidation. So carbon undergo oxidation. Yeah, carbon undergo oxidation. Okay, so when carbon undergo oxidation, it will be the opposite agent. Yeah, so all the substance will become the opposite agent for the process that itself undergo. So since the carbon undergo oxidation process, so carbon will be the reducing agent. Carbon is the reducing agent. Yeah. Okay, next one. So now let's do the second apple to apple comparison. Okay, let's do the second apple to apple comparison. Okay, so now we choose another apple. Yeah, we go to choose another apple. Okay, CO2. Okay, so now I choose CO2 as another apple. So I will compare with CO as well, because I need to choose one further on the left. I must choose one further on the right. So right, I need to choose CO again because it's okay to reuse. It's okay to reuse. No problem one. No problem. It's okay to reuse. So now let's compare again. So on the left hand side, I have CO2. On the right hand side, CO. So CO2 on the left and CO on the right. Remember, when you do comparison, the number 2 in front, don't bother. Number 2 in front shouldn't be included in comparison. The number in front only for balancing. Okay, the number 2 in front only for balancing. So when we compare, number 2 in front, don't bother. Okay, so now we can compare again. CO2 got 2 oxygen. CO got 1 oxygen. So 2 oxygen become 1 oxygen. So again, we know what happened again. So 2 oxygen become 1 oxygen, lose. CO2 lose oxygen. Yeah, CO2 lose oxygen. So when we know CO2 lose oxygen, so lose oxygen means reduction. So CO2 will undergo reduction. CO2 now undergo reduction. So now we know CO2 undergo reduction already. So undergo reduction, you will become agent. Okay, when you undergo oxidation, you will be opposite, reducing agent. When you undergo reduction, you will be the opposite. Opposite is oxidizing agent. Yeah, so oxidizing agent. So now we know already CO2 is oxidizing agent. Okay, so now we settle the whole apple to apple comparison already. Same thing in this question, if they ask us, is this a redox reaction? Is this a redox reaction? The answer is yes, it's a redox. Why? Because we have oxidation, we have reduction. So the oxidation and reduction process, 2 processes happen at the same time. So we have 2 processes happen at the same time. So this is a redox reaction. Okay, so I hope all of you get some rough idea how to play with the oxygen method. Okay, so as a summary, what to do? First of all, when you get a chemical equation, you must do apple to apple comparison. Yeah, you need to do apple to apple comparison. So to do apple to apple comparison, you must choose the right pair. Choose the right pair for comparison. Okay, to choose the right pair, choose one further from the left and one further from the right. Yeah, one further from the left, one further from the right hand side. After you choose the right pairing, okay, then you can compare. When you compare left to the right, left to the right. Okay, and it is okay if you choose the apple more than one time. Yeah, sometimes the apple can be reused. Like this case, carbon monoxide. This apple I compare for 2 times. Yeah. So it's okay for us to reuse the same apple to compare. Yeah. Alright. So that is what we need to know. And do remember, when we do apple to apple comparison, all the number in front the chemical formula is not important. All the number in front the chemical equation is not important. Those numbers only for balancing. Yeah, so that is what you need to know. Okay, so these are total 3 examples. Hopefully these 3 examples can give you some rough idea and help you to understand better how to play around with oxygen method. Okay, so after we learn oxygen method, there is another one more method we need to learn in today's lesson. Okay, there's another one more method we need to learn in today's lesson. There are total 4 methods. So now we have learned oxygen method already. So let's say now we go on with hydrogen method. So let's continue with hydrogen method. So same thing, hydrogen method, you can use exactly the same concept. Okay, you can use exactly the same concept as oxygen method. You can use exactly the same concept as the oxygen method, but now we focus on hydrogen. Okay, now we want to focus on hydrogen. Okay, so for hydrogen method, we will focus on whether we gain hydrogen or we lose hydrogen. Yeah, whether we gain hydrogen or whether we lose hydrogen. Yeah, so that is what we need to know. Okay, so let me use one example for demonstration. Okay, and hydrogen method is not so popular. Yeah, so among the 4 methods, this is the least popular. Okay, among 4 methods. Okay, so we have total 4 methods. The one that is not popular, they seldom ask in SPM, is hydrogen method. Yeah, hydrogen method, very rare, but don't ignore, you must know as well. You cannot say, alright, hydrogen method not important, I just ignore. Nope, you still need to know the concept and the basic of the hydrogen method. Okay, so let me use one example as demonstration. Yeah, okay, let's say we have this equation, H2S, hydrogen sulfide, react with chlorine, Cl2. So we get HCl, hydrochloric acid, and then we have S, sulfur. Yeah. So same thing, this equation do not memorize. Most important is understand the concept, understand how it works. Okay, so this question we cannot start yet because it's not yet balanced. Always make sure the equation is balanced, then only we do apple to apple comparison. Yeah, okay, let's balance the equation. So we have 2 hydrogen here, so put a 2 to balance it. So we have 2 chlorine here, 2 chlorine is balanced already, 1 sulfur, 1 sulfur. Okay, so now the equation is balanced already. Okay, so equation now is balanced, we can start now. Let's start now. Okay, so same thing. So now we want to choose the apple. Okay, let's say left hand side, the first apple, I choose H2S. I choose H2S on the left hand side. So right hand side, I need to choose one further to compare. I'll choose sulfur. Why? Because I see something in common. This further have S, this further have S. So they have something in common. So that is the right pairing, the right apple. Okay. So now what you can see here. When you compare, always compare left to the right. Left to the right. So left hand side, the sulfur come along with hydrogen. So got hydrogen. Right hand side, the sulfur do not attach with hydrogen. No hydrogen. Yeah. So from here you can see, on the left hand side, the sulfur sticking with hydrogen. On the right hand side, the sulfur do not stick with hydrogen. So the process now is losing hydrogen already. So hydrogen sulfide lose hydrogen. Yeah, it lose hydrogen. So when we lose hydrogen, so what process is happening? So according to the table, let's go back to the table we learned earlier on. If we look at hydrogen method now, if let's say now we look at hydrogen method. So hydrogen, so now we have H2S become S. So hydrogen gone. Okay, we lose hydrogen. So lose hydrogen. Lose is minus. So minus. So lose hydrogen. So the process, it's oxidation. Yeah. So this table is very, very important. Make sure you practice on that. So now H2S lose hydrogen. So H2S will undergo oxidation process. Yeah. Losing hydrogen means oxidation. So now we already know hydrogen sulfide undergo oxidation. So when you undergo oxidation process, you will be automatic become opposite agent. Oxidation process, opposite is reducing agent. Okay, so we already settled the apple comparison for the H2S. So let's continue with our apple to apple comparison. Now we will go after chlorine. Let's go for second apple on the left. Okay, chlorine on the left, compare with HCl. Okay, so now on the left hand side Cl2, on the right hand side HCl. So what you can see here, this Cl2 versus HCl. So left hand side the Cl2 don't have H. Right hand side the Cl come with H. No H become got H. So gain hydrogen. So the process now is actually gaining hydrogen. Okay, gain hydrogen. So now we can see this fella Cl2 gain hydrogen. So you can write Cl2 gain hydrogen. Okay, Cl2 gain hydrogen. So when we gain hydrogen, the process is this. Go back to the table. So when we have hydrogen and when we gain hydrogen, the process is reduction. Yeah. So now chlorine gain hydrogen, so chlorine undergo reduction. So when chlorine undergo reduction, so therefore we will know chlorine would be our oxidizing agent. Yeah, chlorine will be our oxidizing agent. Yeah, so we have already complete our apple versus apple comparison. Okay, apple to apple comparison. This is how it works. Okay, so you can see the concept, the method is same as the oxygen, but now we are focusing on H. So now we want to see whether you gain the H or you lose the H. Okay, so everything start with a good apple comparison. Yeah, okay, so that's it. So that's everything you need to know for oxygen and hydrogen method. Okay, so now I'll show you a special case. Okay, sometimes it's okay for them to ask the question 2 in 1. Okay, sometimes they might have a 2 in 1 special case. This is quite rare. So this is a types of the K-bar critical thinking, or we call HOTS, higher order thinking skill. K-bar, or we call HOTS, higher order thinking skill question. Okay, sometimes they might use 2 in 1. Okay, what do we mean by 2 in 1 here? Example. Okay, let's say we have NH3, which is ammonia, and we have CuO, copper oxide. Then it becomes nitrogen gas, it becomes water, and it becomes copper, let's say. Okay, don't memorize. Again, this will be given, so please don't memorize. Your main concern is how it works. Yeah. Okay, now as usual, let me balance the equation first. Let's balance the equation, then only we kickstart with our apple to apple comparison. Okay, put a 2 here to balance it. So put a 3 here, put a 3 here, and put a 3 here. Now it's balanced. Okay. So now we already have a balanced equation. Let us start with apple versus apple. Okay, apple comparison. Okay, now, so let's choose one further on the left first. So left hand side, let me choose ammonia as the first apple. So right hand side, I got 3 apple. So to compare, I'll see something in common. Okay, I'll choose nitrogen. Because here I have N, here I have N, something in common. So at least they are related. They must be related. Okay. So now I already choose the first apple. So let's compare it. So my first apple, ammonia versus nitrogen. So as you can see, left hand side, the nitrogen sticking with H. Right hand side, the nitrogen do not stick with H. So we can use hydrogen method here. So we can write like this. Okay, we can write like this. Ammonia lose hydrogen. Yeah, the ammonia lose hydrogen. Because as you can see, on the left, we have 3 hydrogen. On the right hand side, no hydrogen at all. So when ammonia lose hydrogen, it's oxidation process. So ammonia is oxidized. Or you can say ammonia undergo oxidation. Okay, ammonia undergo oxidation. Okay, so now we know ammonia undergo oxidation process already. So then we can make a conclusion. Ammonia will automatically be the opposite, reducing agent. Yeah, ammonia is our reducing agent. Yeah, so that is everything we need to know for ammonia. Yeah. So that's it. So now let's look at another one. So let's choose another apple, which is copper oxide. So copper oxide is 1 apple on the left. So we need to choose 1 more apple on the right. We need to choose 1 more apple on the right to compare. So we will choose Cu. Because only CuO and Cu, they are related. If you choose CuO and nitrogen, nothing in common, no relationship at all. So CuO and water also no relationship. Yeah, because you see, although here got O and here got O, but Cu become hydrogen, totally not related. Nonsense. Totally not related. So we will choose CuO and Cu, because at least both of them have Cu, something in common. Yeah, so let's do the apple to apple comparison. So CuO to Cu, as you can see, CuO got oxygen, Cu don't have oxygen. So now we can play with oxygen already. So let's write it out. So copper oxide now, okay, so our copper oxide now lose oxygen. Yeah, copper oxide lose oxygen. Since copper oxide lose oxygen, so what process it undergo? Lose oxygen, it's reduction process. So losing oxygen is reduction process. So you can write copper oxide is reduced, or you can write copper oxide undergo reduction. So the table is very important. Okay, please always revise back the table. So the copper oxide now undergo reduction. So when copper oxide undergo reduction, it will be the opposite agent. Opposite is oxidizing agent. Okay, it's oxidizing agent. Yeah, so that's how you do. Okay, what's so special about this question? Why I say this question is a bit special? Because I'm not sure you realize or not, This question actually we are using two methods. Okay, ammonia we are using hydrogen method. But for the copper oxide we are using oxygen method. We are using two methods at the same time. Yeah. Just now if you look back all the example, we only use same method. Okay, we use only oxygen method or only hydrogen method. So this question, if you realize, we are using both. Okay, we are using both method. Okay, we have total two methods here. Yeah, oxygen method and also the hydrogen method. Two method we use it at the same time. So you don't need to purposely memorize. You don't need to purposely memorize. You just follow the flow. You follow the flow naturally. You follow the flow naturally. Just choose one apple on the left and one apple on the right. That is good enough already. Yeah? Okay? But this kind of question considered very rare. This is a very, very rare question in SPF. Okay? Alright. So same thing. Okay? So that is how it works. Okay? So hopefully you have a better idea. Okay? You have a better idea. You get some concept on how it works. Okay? Another one more thing I want to highlight here. Some of people asking, Sir, Mr. Martin, what about the water? What about the water here? So we didn't compare the water at all. It's okay. You don't need to compare all the apples. Sometimes it's not the must. Okay, it's not a must. Okay, to compare all the apples. Okay, you don't need to compare all the apples one. Okay, example like this. Okay, so left hand side we have apple number 1. Apple number 2, right hand side apple number 3, apple number 4, apple number 5. Okay, let's say. Alright, so let's say another left hand side I have another one, apple number 6. So you don't need to compare all one. Okay, you just need to make sure you have two comparison will do. You just need to make sure you have two comparison. Example, I can choose apple number 1 compared with apple number 3. That is the first comparison. I can choose apple number 2 compared with apple number 5. That is the second comparison. That is good enough. You just need to do two comparison will do. Always make sure that if you want to do two comparison is enough. Yeah, two comparison is already enough. You don't need to go beyond. So in this case, we already have two comparison. This is the first comparison. And this is the second comparison. Therefore, we don't need to do the third comparison for the water. Yeah. So this is a very important concept that you must know. Okay. So hopefully by this lesson, you get to understand a few important concepts. You know what do we mean by redox. You do understand 4 methods to decide whether the process is oxidation or reduction. And remember, a very simple way to memorize is look at the first letter. If the letter in front is the same, put plus. If the letter in front is different, put minus. That is a very simple tips for you to memorize. Yeah? And always remember, all the substance always be the agent which is opposite. Always be the agent which is opposite to the process that itself gone through. Yeah? So this is very important. And when you want to do redox, you must know apple and apple comparison. You must know how to do apple and apple comparison. Okay, so that is what you need to know for today's lesson.